Hello, today we will be talking about 1.8 inequalities with other types. That means we are talking about the polynomial inequalities, rational inequalities, and application. For the polynomial inequalities, we need to keep few things in mind that always rewrite the equation in the journal or the standard form if it is not in those forms. And you should find the boundary conditions, or another way to say it is called the critical values. The word critical values or critical points is very crucial from the perspective of calculus as well. When you will learn calculus, you will often see these words: critical points, critical values. So these are the values that make the function 0 or undefined. When we are talking about the word undefined, we are looking for something called asymptotes. You will learn about asymptotes in the chapters that we will learn in this course. So, what are critical numbers? Critical numbers, they are the numbers where the function's rate of change is altered. Altered means it is changed. So where the rate of change is a little bit shifted, a little bit moved, or a little bit altered, whatever words you want to use. So those points are called the critical points. Let's understand polynomial inequalities with one example. So we have one example right here. By now you know how to factor the quadratic. So you can easily factor the quadratic, and we can get x plus 2, x minus 3, which is less than 0. So this is my first step. So the first step to solve all of these is to factor it. The second step is to find the critical points. Critical points will be minus 2 and 3. So basically what I did, I put x plus 2 is equal to 0 and x minus 3 is equal to 0. The third step will be to find the intervals to test. So the intervals will be what? We have negative 2 and it is less than, that means it is not included. So the first interval will be negative infinity to negative 2. Then the second interval, the right hand side interval will be 3 and infinity. And there will be one more interval that is between negative 2 and 3. So there are 3 intervals. Why everything is open? With infinity, it will be the interval will always be open. But negative 2 and 3, they are open because we have the inequality as only less than. There is no inclusion. After this, our next step, the fourth step, will be to pick any test point in these intervals. That means between negative infinity and negative 2, I can pick and choose any test point. And on those test points, we will check our factored form. So let's see. Let's select between negative infinity to negative 2. We can select test point as x is equal to negative 3. Between 3 and infinity, let's select the test point as 4. Oh, I think I forgot to write the third interval, which is negative 2 and 3. So let's find the test point for negative 2 and 3. So for negative 2 and 3, I'm selecting 0, and between 3 and infinity, I will select x is equal to 4. You can select any point, but that should be between the interval. After you select the test point, the next step is to check. So you will check not in the original equation. I would prefer that I will check in the factored form. So if we check these test intervals, we are not calculating it. So there is no need to calculate for every test point. We will just check whether it will be positive and negative, and what will happen with the positive and negatives. For example, x plus 2 will give you a negative answer. X minus 3, when you plug x is equal to negative 3, will give you a negative answer. So negative and negative will be positive, and positive cannot be less than 0. So this test interval, I cannot have any value between this test interval. For x is equal to 0, 0 plus 2 will give you a positive value, and then we have a negative value. That is a negative answer, because positive and negative multiplied together is a negative. So it holds true. Let's test for x is equal to 4. So I will get a positive and a 0, and positive cannot be less than 0. So this test interval will also not hold true. So the only interval that will be the solution for this equation will be -2 and 3. So again, I am emphasizing the point that you just have to evaluate the signs, no need to calculate every single time. So my answer is open intervals -2 and 3. Let's take one more example and we will follow all the 5 steps. So this time we have 4x squared minus 5x is greater than 6. So step number first, factor it. So if we factor it, I will bring 6 on the left hand side to factor it. So we will get x minus 2, 4x plus 3 is greater than 0. This is your first step, factor. What is the second step? Find the critical points. To find the critical points, you will write the factored form equal to 0. You will get 2 critical points here, x is equal to 2 and x is equal to -3/4. What is step number 3? Find the intervals. So again, there is no equality in this problem. It is only greater than. So it will be open intervals. So -∞ to -3/4, then -3/4 to 2, and finally 2 to infinity. What is step number 4? To select the test points between these intervals. These test points, you can select any test point. You don't have to select what I am selecting. You can select whatever test point, but it should be in between that interval. So for the first one, I selected -2. For the second interval, I selected 1. And for the third one, I selected 3. Now step number 5, check these test points. So we have the factored form. Let's check. Again, when we are checking, there is no need to evaluate. Just check whether it holds true or not with the inequality. So if you follow these 5 steps, your answer will be correct every single time. So let's check. With x minus 2, 4x plus 3 greater than 0. Again, we are just checking positive and negative. So with -2, we will get a negative and a negative. So negative and negative will be positive, and positive is greater than 0. It holds true. So this is valid. Let's check the test point. X is equal to 1. So I will get a negative and a positive. So negative and positive will be negative, and negative cannot be greater than 0. So this is not our test interval. So for the last one, let's check it really quick. So as you can see in this one, both of them are positive. So positive is greater than 0. So this test interval will also work. Now in the previous example, we just had the one solution, right? One test interval. Now we have 2 test intervals that are the solution. So how to write it down? Watch carefully. So we can say our answer is infinity to negative. It should be -∞. I forgot to write -∞ in both up and down. And union 2, infinity. U means and. So again, I am emphasizing on example 2. I forgot to write -∞, -3/4. So it should be -∞. What we can conclude here, with polynomials will have solutions on, can have the solution on 2 test intervals, right? Okay. Now the second scenario, The second other type of inequality we will be discussing is rational inequality, but before that I'm writing one question down. Please try to solve it. Give it a try. Follow these 5 steps and try this problem out. Now the second thing is the rational inequality. So the first is done. Now let's do the rational inequality really quick. So the word rational, as the word suggests, it is a numerator and denominator, right? It is the quotient form. So basically with the rational inequalities, we will do the same thing as the polynomial. So write it down, take a note. Do the same thing as polynomial, but to find the critical numbers, we will evaluate denominators as well. Because critical numbers are where the function will be a 0. So function will be a 0 where the numerator will be a 0, or the function will be undefined where the denominator will be 0. So that is why we will evaluate the denominator as well. The another thing that we need to keep in mind is to write inequality in the standard form with rational exponent on the left hand side and 0 on the right. If you follow this, it will be easier for you to solve the equation. So take the rational expression, everything, all the numbers on the left hand side, and leave 0 on the right hand side. So make a note for yourself. On the right. This is very crucial. Okay, let's understand with one example. So we have 2x minus 7 divided by x minus 5, and everything is less than equal to 3. Now, as it suggests, take all the numbers on the left hand side. So we can rewrite, and then we have to take the common denominator as well. After this, take the common denominator, just like you will solve the fraction, subtracting the fractions. So this will give you 2x minus 7 minus 3 times x minus 5, and everything divided by x minus 5, which is less than or equal to 0. Let's clean this mess up, and you will get negative x plus 8 divided by x minus 5, which is less than or equal to 0. Now to solve this, I can multiply both sides by x minus 5. But what are the critical points here? To evaluate the critical points, we are evaluating the numerator and denominator both, because the numerator will make the equation 0 and the denominator will make the equation undefined. So we have 5 and 8. So for your understanding, you can write it down. 8 can be included, but we'll make it 0. And 5 will make the denominator 0, so that is nothing but undefined. And that is the basic understanding of critical points, where the function is 0 or undefined. And undefined, again, we will be talking about asymptotes with regard to that. So the next step is to write the intervals. So step number 3, write the intervals down. So we will have 3 test intervals, negative infinity to 5. Make sure to write negative infinity. I made a mistake in example 2, where I didn't write negative infinity with 3/4. 5/8 and 8 and infinity. Excuse me. Now step number 4. Find the test points between all of these test intervals one by one. You can select any point you want. I'm selecting 0 for the first interval. For the second interval, I will select 6. And for the third interval, I'm selecting 10. Again, there is no need to evaluate, just check the symbols, whether it's positive or negative. So the 5th step is to check. Let's check one by one. Let me write the factored form. Okay, so let's check the first test interval, x is equal to 0. So it is a negative. So it holds true. For the second one, it is a positive and a positive, which is not possible. And then for the third one, we are getting negative and a positive. So negative and positive will be a negative only. And that means it holds true. So we have 2 intervals that are the solutions for this problem. And when we have 2 test intervals, we use the symbol of u. So we can say negative infinity, comma 5, union 8, comma infinity. See, 5 and 8, they are not included because 5 and 8 interval, that doesn't hold true. Now the application part. Let's take one example. In this example, we will try to find the domain of the function. Now, we have a radical. So what we are trying to find, what is inside the radical, because it's a radical, so it needs to be defined for real values, right? So first thing first, let's factor it out. So we have 64 minus 4x squared. This should be greater than or equal to 0 because it needs to be defined for the real values, right? So we are taking greater than or equal to 0. If it is less than 0, then it is not defined for the real values, then the imaginary number comes into the picture. That is the reason we are taking the inequality as greater than or equal to 0. So let's factor it out. We can factor in this way. And then we get 4 minus x and 4 plus x greater than or equal to 0. So the factored part is done. Step number 1 is done. Step number 2 is to write the critical numbers. So what could be the critical numbers? Critical numbers will be negative 4 and 4. Negative 4 and 4. Now step number 3. Write the intervals, test intervals down. So the test intervals are, again, we have negative 4, right? And it is equal to, so negative 4, comma, negative infinity, negative 4, then negative 4, 4, and then 4 and infinity. See, negative 4 and 4, they are not in the closed brackets. The reason is they are my critical points, right? Now, let's select any test points. So I selected negative 6 for the first one, 0 for the second, and 5 for the third. Again, do not evaluate, just check positive and negative aspect. So the 5th step is to check. So let's check the first test point. Now, we have a negative, so be careful when writing the negative down. So we have 4 minus 6, that will become positive. So it will give you a positive and a negative, and that will be a negative. And negative cannot be greater than or equal to 0. So the first test interval, it doesn't hold true. Let's test the second one. For the second one, if you plug 0, both of them are positive. So positive and positive, which is greater than or equal to 0. So the second test interval will hold true. Let's check the third interval. So we have 4 minus 5 and 4 plus 5. Now 4 minus 5 will give you a negative value, but 4 plus 5 will give you a positive value. So here we are with the mixture of negative and positive, and when they interact it is a negative, so it is not a possibility. So the only inclusion part, the domain is, now because negative 4 and 4 is selected, so we have the domain as negative 4, and 4 is the domain because the inequality has the equal to sign. That's why we can use the closed interval, because the problem says greater than or equal to. I hope this has been helpful, and please practice more. With this we are done with chapter 1, and I will see you with chapter 2 videos.